All right, as you have been continuing going through linear equations, functions, we are now going to look at solving linear equations and then applied problems and then finding the zeros. So an equation is a statement that two expressions are equal. So they have to have an equal sign. And when you solve these equations, as you're going to see, as we teach in algebra, we always say what you do to one side, you have to do to the other side. Otherwise, it's no longer equal, right? So you're just trying to keep it balanced the entire time. You deal with different types of equations, but a linear equation in one variable is an equation that can be expressed in this format. But to me, how I remember a linear equation is the variable, because it may not always be x. The variable, the highest exponent is 1. So that's kind of like there's a 1 right there. And so if I'm looking at equations that have the same solution, I can say that then they're equivalent, because if I plug 1 in here, 2 times 1, and then 2 plus 3 equals 5. So x equals 1. So they may not always look the same. So you have to be careful with that to see if they're actually equivalent. Meaning, now in this case, if I plug in 1, okay, I get 0. So x equals 1. These two are not equivalent. When you're going through solving these, and this is where I said what you do on one side, you have to do on the other side. If I start with an equation and I add c on one side, I have to add it to the other side. They call this the addition principle, because when we subtract, we just say adding the negative. And then if you multiply one by a value on one side, you must multiply on the other. And again, they call it multiplication because you can divide. If we're doing something with division, we could say multiplying by the inverse. Again, all of this is getting you prepared to look at more with linear models, with applications. And I know students, a lot of times will struggle and say, well, word problems are, so hard. I mean, I love word problems, right? Because it finally tells me where I'm going to use all of this. And there's some techniques that, we'll practice in this course together. The first thing is figure out, what is the problem, right? That you have a problem here. Best advice I was ever given was to draw a picture. If it's data, graph, make a list of everything that you know, what you don't know, what you're looking for. Charts and tables are always nice. And then you could even, just kind of by looking at it, make a guess. Then you start to translate it into the math language, right? And this is where into an equation, and then you carry out and you solve it, and then you check it and state your answer. So, as I keep saying, this stuff is used everywhere. Right here, student loans. So it says Demarion's 2 student loans total $28,000. One loan is 5% simple interest, and the other is at 3% simple interest. Where simple interest is a formula of just the principal times the rate times the time of the loan. It says after 1 year, Demarion owes $1,040 in interest. What is the amount of each loan? So based on these words, and this is where sometimes a table might be better, we start with what we see as unknown. So let x equals the amount borrowed at 5%. Well, if they borrowed, and going back looking here, if the 2 student loans total $28,000, then if we're letting x be the 5%, then the next loan has to be what's left over of the $28,000, right? And as you can see, those total to that. We have the 5% and the 3% both at 1 year. To be able to find the amount of interest, as you heard me mention, it's the amount borrowed times the rate times time. So x times 0.05 times 1, how we get this. Same thing here, multiply it out. And it said the amount of interest was this $1,040. And so now I have an equation. And so I can simply carry this out and work it out by first distributing 0.03 times 28,000, distribute 0.03 times the negative x, and just continue through the solving process, collect like terms, throw the 840 to the other side, divide both sides by 0.02, and I see I get this 10,000. So if x is 10,000, then the other loan would have been 18,000. And we always like to look at this in check, right? And so if I actually take these values that I got, the 10,000 and 18,000, and I do the 10,000 at 5% interest and the 18,000 at 3% interest, I can see when I add these together, my answer does check and I get my final result. So don't let, word problems, I know I went through that very quickly, but you want to slow down, you want to think about it, write what you know, find what you don't know, what you're looking for, and that becomes your variable. The last part is just stating that if we have an input value of c of a function, the 0 of this function is when it outputs a 0. So if you go back looking at equations, if you remember, we had the y equals 0. So if y equals 0, or we input something, a value, and then we get our output of 0. This is a linear function with m does not equal 0, has exactly 1 0. If you think about it, what is a 0 of a linear function? It's where it's actually crossing the y-axis, correct? Because you have a value here, we could call it for x, and if your output is 0, that's your y value.